Hey guys, welcome back. So in this today's session we are going to see about the why do we require error correction or error detection method at the receiver side. Then one more thing, so how we can able to find out whether the received information is correct or not at the receiver side. So for example, let us say, so I'm going to consider some information, right? So let me take some information, right? So this is my transmitter, nothing but my transmitter PC. This is my receiver PC, right? Now if I say that I'm going to send this information 1010, the received information is 1011. It means that you can able to identify the received information is error. How we are able to find out? Because we know transmitter information as well as the receiver information, so that you can able to compare with the transmitter to the receiver, so that you are identifying error. But in real time this cannot be done. It means that the receiver, this is the receiver mission, right? Receiver mission does not know anything about the what is the information that is sending by the transmitter. Now what is the meaning of this one? If you observe here, so here I am going to take the white color, right? So because this is whiteboard, I am going to take the white color. So here I am going to write some number here. So here I am going to write some number at the transmitter, something I am going to write, right? So this number I am going to write. So this number I am not going to reveal to you, but the information received is something 10110, right? So inside of this I have the information, but I am not telling the what is the information I am sending from the transmitter. Just I am not telling you, right? So now this is the information we received. Now see, now tell me that whether the received information is correct or not. In earlier case, we know the transmitter information, receiver information, so that we are performing the comparison operation to find out error or error free. At this point of time, I am not telling the what is the information which I transmitted, but I am telling you that this is the information received at the receiver end. Now receiver mission has to identify whether the received information is correct or not. How we can able to find out this one? We cannot able to find out, right? In real time also, the first point is that the receiver does not know anything about the information sent by the transmitter, right? It means that the receiver will receive some information without knowing the transmitter also. It should be able to find out the error detection as well as the error correction. Now question is that if you don't know transmitter information, how to find out whether it is error or error free, right? So for that we have something concept called as the redundant bit or extra bit values, right? That is what we called as the redundant bit or extra bit value. Now what is the use of this redundant bit or extra bit value? Means suppose this is my data, right? So this is my transmitter information, some data which I need to send from the transmitter to the receiver, right? So which I need to send from the transmitter to the receiver. Now if you observe here, if you are sending this data from the transmitter to the receiver, you cannot able to find out whether the information is received correct or not. No one can able to find out this one. Now idea is that if you want to find out that information is correct or not, so for this one we need to add the extra bit mechanism. Why we need to add the extra bit mechanism is, nobody invented. If you are sending the same information from transmitter to the receiver, at the receiver, even though if you don't know anything about the transmitter, you cannot able to find out. So for that what we required is, we required something called as the extra bit mechanism. Those extra bit we called as the redundant bit. Redundant bit or extra bits are the same, right? So by adding the extra bit, what is the use of this extra bit mechanism is, at the receiver end, by using of this extra information, we can tell that whether the received information is correct or not, even though if you don't know what is the information sent by the transmitter, right? So for that, so we have something called as the generating function. For example, if you don't understand, if you remember even parity or odd parity method means, so these number of ones we have. Suppose for example my information is 101, this is my data information. For that we need to add the extra bit value. That extra bit value we called as the redundant bit values, right? So according to even parity, if total number of ones are even, then it is called as the even parity, right? So count the total number of ones here, 2 ones, right? 2 is even number, right? So what is the extra bit value? Only one bit we need to add, right? So 0, right? So it means that the generating function of the even parity will generate the value equal to 0. Now what is the transmitted code word? It is the combination of your original message bit value as well as the extra bit or redundant bit value. What is the message bit value as per the given question? 101 plus What is the extra bit value we need to add? As per the even parity, it is 0. Now what is the transmitter code word? 1010, which we need to send from the transmitter to the receiver. Suppose if the code is received something like this. Now which parity method we have used? Even parity, right? Now just count the total number of ones. Total number of ones 3, right? 3 means odd number or even number? Odd number. It means that do we have the error or not? As per even parity, if 3 ones are received, that is we have the error. So it means that if we can send the same transmitted information as it is, there is no way to find out the error or error free. But here how we are finding the error or error free? By using something called as the even parity method, that is nothing but the redundant bit or extra bit. So whatever you are studying, either even parity, odd parity method, or it may be Hamming method, or it may be checksum method, or it may be CRC method, some other method, for original information we need to add the extra bit, then only we need to send the information from the transmitter to the receiver. By using this extra bit, we can able to find out whether the received information is correct or not. If you don't understand this one, so in the next class we are going to solve problem based on the checksum method, CRC method. If you don't know this basic reason or basic logic why we need to perform error detection, error correction, how it can be done, then you cannot able to understand practically how to perform the checksum operation as well as the CRC operation for error detection at the receiver side. If you see that at the transmitter side, this is my data or information, right? What is that information? This is my information. Whatever the method you are using, based on that it will generate the extra bit. Now see that along with this message bit value, nothing but this message bit value, we are adding this extra bit, then this information will be sent to the receiver. So here we have the checking algorithm, like here we have the even parity, counting ones, right? Like that, based on whatever the method we are using, here we have the checking function. As per the checking function, if the received question answer is correct, then it will accept that bit. If the something it is rejected, rejected means if something it is received is the wrong, now what it will do means it will ask the transmitter to retransmit the information again back, right? So this is the basic fundamental for the error detection, error correction, how to add the extra bits or redundant bit value. In the next class we will see how to perform the checksum method as well as the CRC method, right? Again we will see some more basic concept of the particular redundancy checker, then VRC is there, LRC is there, those two concepts also we will try to cover. Thank you.